Okay, we have seen that the velocity potential follows Laplace equation. So using this we can solve this kind of a problem where this is a cylinder and a free stream flowing with velocity of u infinity. So a flow will be of this sort. Okay, so we'll see how this is done. Before that, we'll have to learn how what this Laplace operator is for polar for any coordinate. Mainly we have to do it for polar and spherical. Spherical coordinates, right? This will be equal to 1 by h1, h2, h3 d of d rho 1 h2 h3. Just remember this, and after that there is the rest of the process is a no-brainer. Rho 2, I'll tell you what this rho and h's are. Here 1 is in the denominator, 2 here 2 is in the denominator. For polar coordinates, cylindrical coordinates, rho 1 is 1, sorry, h1 is 1, h2 is r, h3 is 1, rho 1 is r, rho 2 is theta, and rho 3 is z. Just put these things over here. We have del square psi is equals to 1 by r d of dr r d psi by dr plus d of d theta 1 by r, h2 is r goes to the denominator, d psi by d theta plus d by dz r d psi by dz. C square psi is equals to 1 by r d dr plus 1 by r square d square phi by d theta square plus d square phi by dz square, right? Now for this problem, this looks like this. This is the stream that is flowing across it, right? So this is the z direction. Now z is very large, and this is symmetric across the x plane. So we have any differential with respect to z as 0. So this can be made 0. Right, so we have delta square psi is this 1 by r d of dr r. Right, now what we will use is known as separation of variables. We will say that phi, which is a function of r comma theta, can be written as a function r which only depends on the radius, and t, which is a function of theta. So we can write this as, we will replace phi is equals to rt over here. We can write as 1 by r, and this is equals to 0, right, from the Laplace equation. 1 by r d of dr r d is, this is replaced by rt, so this t will come out. Over here the r will come out. Here only the t remains, r has gone out, is equals to 0. When we bring this, so this is, we take this term over here and bring all the r's on this side. So we have r divided by capital R. This r goes up, comes down. Is equals to minus 1 by t d square t by theta square is equals to, now we will put n square. This is known as the separation constant. We will work with this portion first. We have r square sorry, r by r d of dr r dr by dr equals to n minus n square equals to 0. R square, using chain rule, d square r by dr square plus r dr by dr minus n square. This kind of equation is known as Cauchy-Euler equation. This can be solved by considering r to the power of m. So dr by dr is, these are actually all ordinary differentials now. M r to the power of m minus 1 d square r by dr square is m minus 1 r to the power of m minus 2. Now if we substitute this over here, we get m minus 1 r to the power of m plus m r to the power of m minus n square r to the power of m equals to 0, m square minus m plus m minus n square is 0. We take r to the power of common and remove this, so we have m equals to plus minus n. So we have r is equals to a1 r to the power of n plus bn r to the power of minus n. Okay, so this is r. We have to find the same. We have to find what theta is. Let me use a different color. So we have 1 by t d square t by d theta square plus n square equals to 0, or d square t by d theta square plus n square to 0. This is m square plus n square equals to 0. The complementary function and raised to 0 equals to plus minus I, right? So we have t is equals to Cn cos n theta plus dn sin n theta. So if we want, so we have phi, which is r into t, have phi the summation of n is equals to, what we can do is that we can also use some boundary condition over here. This is the sphere. We can say that over here and here, and if the radius is a, we can say that r equals to a and theta equals to 0 comma pi, we will have a stagnation point where u is equals to 0. So we will be differentiating this with respect to theta. dt by d theta is equals to Cn minus Cn sin n theta to n plus n dn cos n theta. So we can say that for this to be 0 at theta 0 comma pi, we will have to make this as 0. This is automatically 0. This will be n dn equals to 0, so dn is 0, right? So this term goes out. Psi is summation of n 1 0 to infinity a n r to the power of n plus b n r to the power of minus n to cos n theta. What we have done is that we have taken Cn and an into Cn as a constant. It's an or an dashed. Okay. So is the phi for particular. This is the general solution. Right? Now for n equals to 1, we have phi is a0 plus b0 for this case. This the case of cylinder, we can use n equals to 1, a particular solution, plus a1 cos, sorry, a1 into r plus b1 by r cos theta. We have ur equals to d psi by dr, which is equals to a1 minus b1 by r square cos theta. Now we will use boundary condition. First is no penetration, which means that at all points ur equals to 0. So we have a1 minus b1 by at r equals to a square is equals to 0. The second is that at r equals to infinity, u is equals to u infinity. So this is u infinity. At r equals to infinity, this is theta. So this is u r. So u r equals to u infinity cos theta, right? So at r equals to infinity, we have a1 cos theta is equals to u infinity cos theta. So a1 is equals to u infinity, and from here b1 is equals to u infinity a square. So we have ur is equals to u infinity 1 minus a square by r square cos theta. U theta is equals to 1 by r d psi by dr is equals to a1 r plus b1 by r minus 1 by r sin theta is equals to minus a1 plus b1 by r square sin theta minus u infinity 1 plus a square by r square sin theta. This is u theta. So this is u theta and this is ur. Now u theta at r equals to a is minus 2 u infinity sin theta. Okay, you have to find, you can find stream function also. Stream function, we know that ur is 1 by r d psi by, so d psi by d theta is equals to u infinity 1 minus a square by r square cos theta into r. Psi is equals to minus u infinity r minus u infinity r minus a square by r to sin theta. This is the stream function. We can also find an equation for pressure using, since this is potential flow, we can use Bernoulli's equation. P0 is the pressure at the free stream over here, right? Plus half rho u infinity square is equals to P at the surface of the sphere plus half rho u square. Now at the surface ur is 0, only u theta is there, so we can write P plus half rho, and u theta square is 4 u infinity square sin square theta. Coefficient of pressure is defined as P minus P0 by half rho u infinity square. So P minus P0 is half rho u infinity square into 1 minus 4 sin square theta divided by half t square. This is 1 minus 4 sin square theta. So if this is the sphere, and let's say this is 0 degree, 90 degree, 180 degree, so this is how the pressure profile will look. So if we put Cp, it will start at theta equals to 0, this is 1, maximum is minus 3, this is 1. So it will look like this. This is actual theoretical, but this is theoretical, actually it will be like this. Okay.